This Mixing with Mike tip is on the 4 types of dynamic processing. And one of the things that I think is very confusing to people is what the different types of dynamic processors are and exactly what they do. Most of what you really hear is about Here's a Mixing with Mike tip on the 4 different types of dynamics processing. Now, when working with dynamics processors, you can basically break them down into 4, maybe 5 types. And essentially, the way that we hear about dynamics processors is we hear like compressors and limiters or expanders and gates. And really, those are variations of the same basic function. So this is more fundamental to that. Now, the way that I describe dynamics processing is that the actual audio signal that is being processed in one of 2 directions. So the audio signal itself is either going to get processed downward or it's going to get processed upward. And this depends on the type of signal that you're applying and what you're doing with it. So for example, if we have a signal that passes above a threshold, so the red line here is above threshold, then this keys in compression. And if the compression has a ratio, let's just say of 2 to 1, then what will happen is we will have an output, assuming we have a fast attack and all of that sort of stuff, that is half as much as the signal that passes above, right? So that's a form of downward compression, right? So this is downward compression, what we're looking at here. So that's one basic form. The other basic form is signals that fall below threshold. So if an audio signal passes below threshold and then gets expanded downward, right, then what we have is a downward expander, right? So this is just really simple, an expander or a gate. And again, the function or the difference between a limiter here is the ratio, and the difference between an expander and a gate is fundamentally the ratio. How much downward are we going? So what happens is when the signal falls below threshold, then the audio signal gain is sent downward, right? So these are 2 basic forms of, you have downward compression and downward expansion. Now, you can divide this in half now, and now what I want to do is talk on this side about upward compression and expansion. So when we're dealing with it from this side and we have a signal that passes above threshold, now we have an upward expander, because what we're really doing here is we're inverting the ratio. Sometimes this ratio is represented in a decimal, like 0.5 to 1, that type of thing. Because I should put that in there. Or another way of saying it is a 1 to 2 ratio, right? So for every dB above threshold, 2 dB comes out, and that's called an upward expander. And so this is something that is not only very possible, but is very much in use in a lot of the plug-in processors that are available now. The other form is upward compression. And upward compression can be applied in a few different ways, but fundamentally, signals below threshold would have a compression signal applied to them. So now you're dealing with, again, like a 2 to 1 ratio. So for every 2 dB below threshold, 1 dB comes out. So what that means is that this signal is actually getting pushed up higher, right? So the output signal, resultant signal, is less and then closer to the audible range. Sometimes this form of upward compression is called low-level compression. And in low-level compression, essentially what you're doing is you're taking those low-level signals, a lot of the ambient energy, and bringing that up and making it audible. And what this does is it brings out a lot of the nuances and detail of the instrument. It also brings up noise. So there's something that you have to kind of play with there. And many of these types of processors also have gates that are built into them, downward expanders, so that when you get below a certain threshold, once you brought that signal up, that you're not having noise where you have no audio signal. So that's usually added in. There is one 5th type that I talk about, and this is a form of compression, and it's called mid-band compression. And this is something that was really developed, I believe, by Dolby Labs and Ray Dolby. And what they did is they developed a form of compression that works within a range or an area. And the basic idea here is that you could take signals that, for example, exist between these two thresholds, and it's not really dialed in that way. You would sort of have a fixed width that it would go in, and then you bring your threshold down. So if your threshold was set here, it would basically take all the signals between here and pull this downward, pull this upward based off of the ratio, and then pull the overall gain up. So the idea is that you could take information that exists here in the mid range, in the mid level area, and compress it. And this was used for noise reduction systems with Dolby. That's where the development of that from the analog technology realm came from. So, and these are also available in plug-in processors. So the tips that follow this will go through some of the different types here, and you'll get to see more information about what the different types of processors are. So there you have it. Those are the 4 different types of dynamics processors. So going from there, you can join the live Mixing with Mike classes every Wednesday at 7 p.m. If you sign up for the newsletter, you can actually join the classes live for free every Wednesday night at 7 p.m. by going to mpginsider.com. Thank you for tuning in to another Mixing with Mike tip.